Alright, so I'm going to be looking at question number 4 on the chapter review. And question number 4, if I get my paper out here, I can read it to you. This is chapter 4's review. And so it says 28% of the U.S. adults surveyed are more likely to purchase during a sales tax holiday. So likely to purchase. If we randomly select 10 adults, we need to find out A, what are the chances that exactly 2 more than 2 write a little bit better, more than 2, more, why don't I just say greater than 2, and between 2 and 5 inclusively are likely to make a sales tax, so likely to purchase. And what we're looking at here is an example of binomial distributions. And so for this binomial distribution, our chance of success is 0.28, because that's what 28% success translates into. Our chance of failure is going to be 0.72. These two should add up to 100. And the number of trials we're going to do are the 10 random adults we select. Now, our formula for the binomial distribution is whichever value I put in is equal to n choose x times p to the x times q to the n minus x. And so this is the formula we'll need to use to get this to work as it works through different values. Alright, so let's do part A, exactly 2. And so to get exactly 2, we want the probability of 2. Now our n is 10. Our x is 2. My p was 0.28 to the x. My q was 0.72, and to the n minus x, or 10 minus 2, is 8. Alright, so on the TI-30, you would want to type in 10, hit your probability key, scroll over to NCR and hit enter on that. Then hit the number 2. Hit the multiplication key. And I use the parentheses, 0.28, up arrow 2, hit the multiplication key, parentheses, 0.72, up arrow 8. Let's see if I can get the camera to show that on the TI-30 XIIS here. So let me switch to camera mode. The cord's getting a little wrapped up here. Give me a second. Let's see if that works. Let's come over here, go to the camera, and here's my TI-80. I'm trying to get a shade on this so I don't get that reflection off that light as much. See if that shade works. It works a bit. Alright, so I'm going to turn it on. And what I need to do is I have 10 trials, so I type in 10. I come to the probability key. and I choose NCR, and then I have 2 for my R. I'm going to multiply this by 0.28 parenthesis to the second power times 0.72 to the 8th power, and I get 0.2547. And we're going to round this to 3 decimal places, so 2.255. And so 0.255 is the probability that 2 of the adults that we picked will be likely to make purchases on the tax holiday for exactly 2. Well, for the greater than 2, we want to find the probability, so B, for P greater than 2. Well, what I could do is I could add up all the probabilities of 3, 4, 5, 6, 7. Let me see, is it greater than? Yeah, greater than 2. 3, 4, 5, 6, 7, 8, 9, and 10. Well, that's a lot of probabilities to calculate. It's better to use the complement of every 2 or less. So the probability of greater than 2 is the complement of less than or equal to 2. And so less than or equal to 2 is going to be the probability of 0 plus the probability of 1 plus the probability of 2. What's really, really nice is I already have the probability of 2. That was the 0.255. And we're going to say this is 1 minus the probability of less than or equal to 2, because that's what our complement is. So what we need to do is we need to figure out the probability of 0 and the probability of 1. And I can do this on my calculator. I can use my up arrow key and I can change the numbers. So if I look at the probability of 0, that was going to be 10 C0 times 0.28 to the 0 times 0.72 to the 10th. And so I can up arrow on the calculator and replace the number 2 with 0 in each of the places it shows up, and replace the 8 with 10. And that gives me a probability, again, to 3 decimal places of 0.037. So I'll put that up here also, 0.037. And then the probability of 1 is equal to 10, choose 1, times 0.28 to the first power, times 0.72 to the 9th power. And so I use my up arrow on my calculator again, and I replace these zeros I put in with 1s, and I replace the 10 on the end with a 9. And I get a probability of 0.146. And so if I add these 3 probabilities together, I get 0.438. But what I want is greater than 2, so I have to subtract this from 1. So the probability for everything to be greater than 2 is 1 minus 0.438, which is equal to 1 minus 0.438, or 0.562. And so we used our binomial distribution and we looked for things being greater than 2. All right, so for our part C, where we ask for our probability to be between 2 2 and 5 exclusively, I need to add the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5. So again, using the scroll button on the calculator, I can go in and change the values I already have entered. So I'll start with the probability of 2, which I already had. And that was 0.255. Alright, so the probability of 3, put probability of 2 here, and then we'll add all these up. The probability of 3, again on the calculator, is going to be 10, 3 times 0.28 to the third times 0.72 to the seventh. But I will just scroll up, change my 2 to a 3, and change my 8 to a 7. And that gives me 0.264. I'll do the same thing with probability of 4. Gives me 10, C4, 0.28 to the fourth times 0.72 to the sixth. So updating my calculations on my calculator. Takes me a second to scroll up. And I get 0.180. And then in my probability for 5, which will be 10 C5, 0.28 to the fifth times 0.72 to the fifth. So 2 to the fifth. And I get 0.084. And so if I sum up these probabilities, 0.255 plus 0.264 plus 0.180 plus 0.084, I get 0.783. And that works out the probabilities for this binomial distribution.